In this problem, we were asked to evaluate the sine of the difference of two angles, alpha and beta, where we're given some information about those angles. We're told that the sine of alpha is negative 15 over 17 with alpha in quadrant 4, and we're also given some information about beta. Well, we're being asked to evaluate the sine of the difference of two angles, so let's start by using the angle difference formula for the sine. So this is going to be the sine of alpha cosine beta minus cosine alpha sine beta. Right? And what we'd like to do now is to plug values in for each of these expressions. Right? Well, sine alpha and cosine beta, I already know. They were given to us in the problem. So sine alpha negative 15 over 17 times cosine beta, which is negative 3/5. All that remains is to evaluate cosine alpha and sine beta. Well, to find cosine of alpha, I can look at my information above with the sine of alpha being negative 15 over 17 and alpha in quadrant 4 to put up a reference triangle and figure out the cosine. So I'm in quadrant 4, so I'll use a reference triangle down there. And I want a ratio of 15 over 17, so I'll make the opposite leg 15, the hypotenuse 17. And since we're in quadrant 4, the sine is certainly going to be negative down there. By the Pythagorean theorem, the length of this leg is 8. So the cosine of alpha, we're in quadrant 4, so cosine is going to be positive, and the ratio will be 8 over 17. What about the sine of beta? Well, beta lies in quadrant 3. So I'll put a reference triangle in that quadrant. Cosine is a negative 3/5, so I'll make the adjacent leg 3, hypotenuse 5. Right? And it's negative certainly because we're in quadrant 3. The other leg, by the Pythagorean theorem, has length 4. We're in quadrant 3, so the sine of beta is going to be negative. The ratio is going to be a negative 4/5. So all that's left is to simplify this expression. We'll have positive 45 over 105 plus 32 over 105, which is 77 over 105.